Thanks for the introduction. I'm sorry to 1,000 people for that little delay. And thank you, John. I'll whip through this. But I would like to start with a little story to put this into context. I grew up in central Queensland, and I'm just going to put my timer on so I don't go too long, in a small country town. And I was busy hammering and bashing and welding and stuff with my dad in the shed, restoring old motorcycles to race them. I didn't know what an architect was. I certainly didn't know what one did. But at the end of high school, I put my motorcycle racing career on the back burner to study architecture. I had a ball at uni, but I didn't relate well to the kind of elitist nature of architecture practice. So I left it to race motorcycles again. I ended up in Europe. That's when I got interested in architecture. I saw amazing modern buildings, in particular, the Pompidou Centre, which to me was like an old motorcycle where you can see all the parts and what they do and the role they play in making the thing perform. Miraculously, I scored a job at Renzo Piano Building Workshop in Paris. And working with Renzo, the son of a builder, that's an important distinction for me, was like hanging out with my dad in our workshop. And after 6 years in Europe, I felt extremely fortunate and compelled to pay forward this amazing experience I gained with Renzo. And I wanted to apply it to the most demanding challenges in my home country. So Stephanie Smith and I set up a research group, and we started to study Indigenous and social housing. That seemed to us the most demanding and the thing that still is what architects really need to be helping with, social and Indigenous housing in Australia for us. The problem is so great, I couldn't imagine it being solved by conventional building practices. So I embarked upon a 5-year applied master's research project looking at the application of prefabricated timber portal frames. That was back in 1991. To test my research propositions, we designed 2 pilot projects. Here's the first one. It's a community church near the country town where my mum still lives in central Queensland, built using the segmented LVL portal frame system for my master's research. The frames were fabricated in the south of Australia near Victoria and trucked to site in central Queensland. This LVL portal system, as you can see on the top right slide, allowed top-down construction. This led the unskilled volunteers, part of the church group, to complete the project in their own pace, sheltered from hot tropical sun and intense rainfall that we get in Queensland. Now check out the opaque coatings around the perimeter of the building. We're going to talk about that a bit later. This is the second pilot project. It was on a steep site in Brisbane and was a steep learning curve for all involved. As John has shown, there's a lot of practical things we need to consider. For example, logistics and handling accounts for major load cases. Look at these flimsy portal frames. They're very strong when they're in place, but when they're waving around in the truck and being lifted by builders, that's not the case. And the key thing here too is if it doesn't fit, it's probably the wrong piece. So guys, put your saw back in the truck, please. That's reminding me to say there's a paradigm shift required on site. Also, I'd like you to see these, I think you can see my pointer, these flimsy temporary braces. Some of the most significant injuries on site are caused by temporary props. We'll see a better example of that in the next project. But more importantly, the second project gave me deep insights into the cultural challenges we face introducing modern methods of construction. It caused me to think what it means to be a builder and reminded me of what I witnessed in my dad's life as a motorcycle mechanic. Remember, the uptake of efficiencies and systemization in the automotive industry is well ahead of construction. So it was later in my dad's career as a motorcycle mechanic, he explained to me the lack of satisfaction it had come to him because Now he was being asked to be a parts replacer rather than someone who's to find ways to fix and repair stuff. That was when I realized why he was into really old motorcycles, ones you cannot actually buy parts for. So there was no choice but for us to make these parts. And that is the deeply satisfying bit for a creative, trade-skilled person. So we're asking these teams of builders with generations of making and fixing in their blood and large bodies of available codes and standards that they're very familiar with to suddenly simply assemble things that had nothing to do with making. And I believe it's one of the challenges with DfMA is we are changing the raison d'etre of the industry that we're working with. So a more recent project with Professor James Murray Parks, who developed this system, you can see fully integrated straps, hanging points. Can someone say yes if they can see my pointer, please? And you can also see temporary braces to support, not like those portal frames that were flapping around, but the ropes, thank you, but the ropes are tied, the slings are tied around these temporary bits, which will be sawn off here. Look, they've made it really easy. That is DfMA at its best. Beautiful. But check out this. Now we're talking about that cultural shift. Our beautiful pieces of finished timber, almost finished, just need to be painted, are being used as a bench and a prop. I'm going to talk about scuffed timber a little bit later. So DfMA is about an entirely different skill set and an entirely different mindset. These are the prefabricated panels arriving on site. Now, the team is completely different as well. This building was put together with a truck driver who became the rigger and a few guys, mostly from James's own office. Engineers assembled this building, not builders, no tradespeople. But as John mentioned, more decisions up front. Now, this building was designed by myself while I was at Hassel in collaboration with Sylvester Fuller, and this is the end of day 2. This is Jad's photograph. It looks a bit funny because what we're actually doing is it's a proof of concept. So we were testing a whole lot of different facade modulation and different performance so that for residential and commercial are quite different acoustically and fire. But the cladding is very interesting. I'll talk about that a bit later. It's 100% natural, sustainable yield hardwood sawdust. It's carbon positive. It has less than 0 carbon footprint. It's called WeatherTex. We use it every time we can. But here's the thing. In the amount of time it took me to put this slideshow together, this 380 square meter building was put together faster than that. I'm pretty slow in PowerPoint, I guess. Okay, this is an interesting project in Vincent's Private Hospital, stage 2. I was talking to the builders Build Corp. We had designed these bathroom pods, 128 of them, to be prefabricated, as you can imagine. Build Corp couldn't find any pod manufacturers who could do a cantilevered structural pod. So they set themselves up their own off-site manufacturing facility and they confirmed they would do it again. Very successful. What you see here is one of numerous massive ventilation facilities for Sydney's extensive WestConnex motorway tunnels. To give you some scale, this vent stack is 30 metres high. I want you to notice this banded aluminium in the anodized, these bands in the anodized aluminium. I'm going to talk about that later. But the remarkable thing about this project is what you see above ground is the tip of the iceberg, literally. Underneath are massive facilities of fans and filtration and attenuators and all that. So I had contemplated building these big vent stacks out of a lightweight material, CLT, and I'd also proposed this brick, thin, single-skin brick wall to be assembled robotically. Neither of these two initiatives were taken up by the contractors. My client were the D&C tenderers. So I think that's probably because in the industry there's not enough trusted resources for contractors to draw upon. In comes the handbook for design of modular construction. That's what it's for. So modular construction hasn't had the uptake that we might have expected. I've been fiddling around with this for 30 years and it's still being talked about. Why is that? Technical complexities, and especially in Hong Kong, I understand, regulatory uncertainties or old ways of doing things. The other issue is that early adopters were using it to save money and probably did low quality, so the finance industry has been reluctant to support modular projects. That's why we need this guide. In the beginning, these four gentlemen, and in the interest of time I'll whip through, plus these two gentlemen, set up the committee to write this handbook. They were supported by these wonderful organisations, and here's the front cover. What's the purpose of this? Basically, to get all stakeholders from beginning to end to have confidence in design, including us guys, we designers. If you follow this, you'll have a whole lot of very nice outcomes, including end-to-end project communications, which is a big topic, I think, in our industry. John talked about multidisciplinary work before. The layout, a very interesting set of introductions and conclusions, and 16 chapters A to R, which I'm going to whip through. Naturally, structure is indeed the largest section. And if you understand that probably the buildings we design, 75% of their mass roundabout would be structure, it stands to reason. It's a big topic in this guidebook. The work in the guidebook is backed up by partners in its production, Monash University, through a range of PhDs. Here's one looking at a volumetric module on the back of a simulated vehicle, and the testing the different load cases, whether you're going over a normal road or a rumble strip, or let's say a judder bar if you're a Kiwi, a speed bump if you're an Aussie. But go to Dubai, the taxi drivers call them speed ramps. Too much fun. Monash University, again, PhDs looking at testing finite element analysis versus live experiments. The next chapter is building services, and that's where a lot is going on in Australia. This is the Barangaroo Towers by developed and built by Lend-Lease. Here are A.G. Coombs' response to DfMA prefabricated service modules. Check out the size of these babies. Similarly, Freedon, working at the cutting edge of this area as well on Blacktown Hospital, in the factory, on the site. Facades, John mentioned structural load bearing. This chapter deals with them as non-load bearing. We're back to St Mary's Myer Timber headquarters. This is a facade panel fully glazed, primed and coming into place. The things we're thinking about here when it comes to architecture is protecting these finished products during transportation, access for fixing, how big is your hand, what spanner is required, tolerances, particularly between different materials, concrete as far grosser tolerances than timber and steel, differential movements, again, between those materials. Condensation is a biggie, especially, well, depending on your climate. Maintenance, of course, inspections, replacements, and please think about reuse. We want design for manufacture, assembly and disassembly, please. Architecture, rolling right along. Let's start with the legend himself, early adopter, Buckminster Fuller, the Wichita House, which was an evolution from his work starting in 1927. Look at that beautiful quote, maximum gain of advantage from minimal energy input. And more recently, co-author James Murray Parks talks to us a lot about, mouthful one, this one, more maths, less maths. Beautiful. So when I think about prefabrication, especially if we're talking about different cultures, remote areas, we'll talk more about this in the next webinar, but Kenneth Frampton has taught us to think about place form. Here it is in Bucky's, the thing that comes from the site, versus product form, the thing that's imported. On Aurora Place, we were thinking about this too. Distance and location, probably not such an issue in Hong Kong, but it certainly is in Australia. How far away is your project from a manufacturing hub? And indeed, how far are trade skills coming? If they're coming way too far, they're way too expensive, and that makes a big difference for offsite or prefab. Site access for the trucks and cranes. Weather and materials handling is a big deal. When prefabricated elements are exposed to the weather and water or moisture is sitting in on a steel section, for example, and then it's closed up, in that interstitial space, we're getting degradation that we don't know is happening, and it's a common point of failure. Of course, if we're thinking about timber, then moisture of timber is going to swell it, and the humidity will change the size of that and make it more difficult. We have to think from the very beginning about the typology of our project. Is it a small cellular arrangement of rooms like student accommodation or a hotel? Or is it a larger spans, such as office buildings, school, or indeed an airport? These early choices also include, as John mentioned, materials and suppliers. An obvious example is CLT, cross-laminated timber. Depending on who's manufacturing it, the slabs of CLT will be a tiny bit different. And of course, we're concerned about reducing waste, and we want our modules to suit our materials, and therefore we need to know who our suppliers are, and we need to know that early when we're designing a building. This is one of the pushbacks we get from our clients. They're worried about limited tendering possibilities when we choose a supplier too early. We have to think about volumetric versus flat pack, or a hybrid combination, which John talked about, because of course volumetric, there's no substitute for speed. And for those who are not familiar with that definition, we're talking about, let's say, a hotel room or student accommodation that has the beds inside, the soap, everything ready to go, the salt and pepper if it's a hotel room, and that can just be piled up on site and done. No substitute for speed there. But if you're taking that a long distance, you are transporting air. There's also structural redundancy, because that module has got to be strong, as we saw on the back of a shaking truck. And when we put them together, we get double structure. That's an extra cost that needs to be considered. But of course, the speed issue reduces builders' preliminaries, which are a big part of a construction cost. Repetition versus the ability of parametric models to give the contractors repetition, fabricators repetition, but gives we designers the ability to introduce variation or what we might call mass customization. The expression of the project is important to consider. Here, Bucky is enjoying showing us the radial nature of how this building was assembled. It came in a tube, by the way, a stainless steel tube. And of course, reuse, please. I'll keep banging on about that. Materials and manufacturing. Let's look at the D1 tower, 80 stories tall in Dubai, to prompt a few issues around materials and manufacturing. We designed at Innovaci a timber shade canopy at the base as a transition element between indoor and out. And what we're looking for here is optimization of quality. Our client was happy to go with Hess, and because we hit their client's budget, because we worked very closely with Hess from day one, and we worked very closely with Nippers Helbig, their favourite engineers. So this canopy was not just a whim by the architects, it's the result of a very close collaboration and an evolution of design based on their ability and minimization of waste using their off-the-shelf methodologies and joints versus inventing new ones. We're thinking about lifting and location aids, which I mentioned before. Handling is an important thing for us to think about when we're specifying, particularly glass and metal. We don't want sharp edges. Wet weather protection, I've already mentioned. So John mentioned collaboration and early understanding. Please one of the main challenges in our industry, I think, is absence of communication and understanding of each other's skills. So go and talk to your contractors early. That's what we need to do in DfMA. It's like back in the day. Go and talk to them, learn from them. There's no substitute for seeing what they can do. You must understand the tolerances they can achieve. You need to understand the accuracy they can achieve, which is how, if you specify a size, how close will they get to that? And then there's precision. How close will they get to that on a repeated basis? They are two things you need to understand. There's no substitute for going to have a look. This canopy evolved significantly after visiting their factory several times. Durability. Here's a cracker project, Renzo Piano Building Workshop. That's the one I walked in and got a job with, Bercy 2. Wow, what a blast. But we have to start with the issue of design life. We need to understand the management plan around durability and maintenance and the exposure of that project to the elements. In this case, Bercy 2 looks like this kind of tough shell on the outside because it is flanking the periphery, this massive 24/7 freeway, and it is adjacent to the train station, a TGV, train of grande vitesse. They come in at high speed, jam on their brakes and spew out brake dust. Conventional architecture didn't cut the mustard, which is why Renzo got this job. But of course, we were looking for a soft inside, tough outside, soft inside. So exposure to UV is something, or excuse me, exposure to humidity was a topic on this project, because these arching glulam beams, which run diagonally across this building, and they're all identical in geometry, step from inside to outside. That change in humidity of that timber has not performed well, learning for us. And back on the Gracemere Church, exposure to UV. In Queensland, we have to take that seriously. So the approach here was a bit like when we go to the beach. We've put the equivalent of zinc green, an opaque, light-coloured, reflective coating on the bits that get exposed to sun, like our nose at the beach. And exposure to insect and fungal attack is a big one with timber. You can't quite see it here, but in Australia, we put a 250mm minimum smooth concrete distance between the dirt, where the termites come, and the timber. It allows us to monitor that, and mesh underneath it, of course, too. Sorry, I just hit the wrong button. Durability includes the issue of fatigue, and on this project I led to a hassle. It's another vent stack for WestConnex. We're dealing with a very thin veil of concrete, aluminium over the top of the concrete stack. So thin aluminium moving in the breeze is going to wear out with fatigue. Not too dissimilar to your tinny when you're driving it across the ocean for years. You'll end up with leaks where the rivets are. Maintenance access, this skin, this veil is a metre or so off the concrete to allow for maintenance and access to inspect the elements, not only the lights that are behind, but also the equipment that the freeway operators use to test the air quality. Coatings and batch consistency I raised in the previous vent stack. You saw the big bands. Here you can see them just on the edge, I think. It's a particular issue with anodizing. These little holes here are designed so we can easily replace the panels that are close to ground. Now, when we do that, we have to accept we will get a different result with clear anodizing. Even as you saw, when it's all supplied at once, we get different situations. Now, because we knew that would happen, what we designed is different hole sizes, which is like a dot pattern of grayness, which gave us another game to play with that tonality. The smaller holes, it's an issue of safety as well. We didn't want people to be able to climb this vent stack or indeed get their fingers stuck in the holes. So the holes are very fine, close to the ground. But there's no substitute for testing at scale 1:1. That's what's going on here. Safety, I just mentioned that. It's a very good chapter to look at. temporary erection and transportation, classic, lots to think about there. Compliance with building codes is a pretty big topic, especially in Sydney. In fact, all over the world, where demand for our skills is way outstripping supply. What's happened in Sydney is we've had a significant drop in quality, and no doubt well-controlled factory conditions would be a very big asset in this situation. So guys, get on board with DfMA. It's the way forward for meeting with quality the remarkable demand we're seeing globally. Inspection and verification. If you haven't seen this Four Corners program, ABC TV, from August last year, it's worth a look. It'll give you an insight into what's going wrong in terms of inspections and verification. My friends, Euro Components in Italy, probably global leaders in bathroom pods, they believe that the bottleneck in certification would be relieved by inspecting their Revit model, their digital twin. Their point is, once the pod is built, it's very difficult to inspect the plumbing and the stuff that's in the concrete or in the walls. So please, certify our BIM model and away we go. What a good idea. Traceability is a major importance if you are talking about innovation. Aurora Place, designed by Renzo Piano, was the first building in the city of Sydney to use structural silicon glazing. That is not captive with aluminium. Aluminium is a nasty product. We didn't want to use it. Plus, we want a smooth facade. So the only way we could get that through was tracing every single step of the manufacture of these facade panels and monitoring them to this day. 20 years later, there are panels on the roof that are inspected and exposed to sunlight, and the building maintenance team, the cleaning people, are trained to spot any early signs of failure, and in go the clips to hold it on. The traceability allows us to know exactly which panels might be affected by that failure. Documentation is a big one. We're all familiar with that. It's all about BIM. Check out that for some guidance. If you're not familiar with recyclability, please check out Cradle to Cradle. There are a couple of other chapters later in the book, little ones, on low rise, on relocatable, on digital engineering and lean manufacturing. Worth a read is the McKinsey & Company, The Next Normal in Construction, which was released just a few days ago, an easy read. It talks about lean manufacturing. Check it out. But you know what? I think everyone's pretty aware of the fact that we are responsible for nearly half, let's say 30 to 40% of the impact on climate as listed here. I'm whipping through to try and save time. So we have an obligation as an industry to improve our game. I'm very interested in gender equality. I think DfMA helps that. If you're going to work in the same place every day, it's easier to organise childcare. You're not driving all over town with a ute. These are the UN global goals that float my boat, excuse the pun. Check them out, see which ones you like, and get on board. We can do this, guys, if we work together. We're a big industry. There's 1,000 people here. Let's agree. Grab a hold of this handbook. If DfMA is the next normal, this will be your best friend. It's appealing to read. It's easy to use in real life situations, and it's the only it's the only guide of its kind that we know of in the world. So use this to make your difference. And but please note, it's an evolving document. It's now being adopted as an Australian code. The Canadians are using it. I wonder who's next. Hong Kong, here we come. Ha. So download it here, guys. It's free. It's easy. It's a beautiful PDF. Enjoy. And I think it's time for questions. Thank you very much.